Okay, so we're going to do one exponential growth problem together before I send you to do it on your own. And just to kind of review, this is the exponential growth and decay formula that we've learned, where a of t is the amount at any time is equal to a, or your initial amount, times the quantity 1 plus r, where r is your rate, usually given as a percent. So if that's positive, it's growth, or if it's negative, it's decay. But you're not usually given a positive or negative number, but instead they'll give you that in forms of the word increase for growth, and the word decrease maybe for decay. So by seeing this word increase here, I know that that's a rate that I'm going to add in the problem. And then that's all raised to the t, or to the time. Okay, so that should be review. So let's get to work. The population of Italy is 60.5 million people. On March 8th, suppose 500,000 Italians have COVID-19, and this increases at a rate of 20% per day. How many days after March 8th will half the population be infected? Okay, so the very first part, I'm looking at what is the amount that I care about, and that's going to be half the population, which is 60.5 million, and we'll work in terms of million here. And then I'm just going to multiply that by 1/2. And that is equal to the amount, the initial amount is 500,000 Italians, which I also know that that is 500,000. So I'm going to say that's also 1/2. And then times 1 plus r. In this case, my r is 20%, right? This is going to be my r. So I'm going to say this is 1.2 raised to the t power. And t is what I care about. This how many days tells me t is the variable I should have left. Okay, so now we're going to go ahead and say that this 1/2 and 1/2, when I go ahead and multiply both sides by 1/2, that's going to cancel. All right, so I'm going to have 60.5, or sorry, not when I multiply by 1/2, but when I multiply both sides by 2 to get rid of it. It's just going to cancel each other out. Is equal to 1.2 to the t. Okay, so the next step, you might remember, to get things out of the exponent, we can take the logarithm of both sides. So I can say that log of 60.5, let me make that a little bigger, is equal to the log of 1.2 raised to the t power. Now, a property of logarithms you might remember is that you can take this t, and instead of having it as an exponent, you can multiply it out front. So I can say this is the same thing as log of 60.5 is equal to t now times log of 1.2. All right, so to get t by itself now, we'll just divide by log of 1.2. I can say t is equal to log of 60.5 divided by the logarithm of 1.2. And I'm going to use my calculator now to do the rest. So I can say that the log of 60.5 divided by the log of 1.2 is equal to 22.5. Or in this case, I could say that t equals 22.5 days. Or 23 days, let's round up. So what we've learned in this problem is that in 23 days, if we're increasing at a rate of 20%, half the population of Italy will be infected. All right, so now that we've done one together, go ahead, go out, conquer, rule these exponential problems.